So guys, as you can see, we have D2 high, D3 high, C4 high. See, D2, D3, C4. It is D2 for 1 second, then D3 for 1 second, and C for 1 second. Now let me show you the hardware, what is happening here. Take a look here. This is the hardware. This is our transmitter PIC. We have only 3 pins connected to the receiver side. C4, D3 and D2 connected to the receiver, and then a ground. That is the only thing coming from the transmitter to the receiver. Then on the receiver side, other than these pins, we also have an LCD connected with our selected pin out. Then if I go to take you to the codes, you can see that this is our transmitter code. On the transmitter, we initialize the D2 pin using tris command, and then the default state is 0. Default it will be 0. Then we initialize the D3 pin. Then we initialize the C4 pin. After that, in the forever loop, we make the D2 pin go high, and it remains high for 1 second. After that, D2 becomes low, then D3 becomes high for 1 second, and after that D3 becomes low, and then the C4 becomes high for 1 second. After that, C4 goes low, and this keeps on repeating. And on the receiver side, we first initialize the LCD because we are using LCD for demonstration purpose. Then we initialize all 3 pins. Now see the difference. On the transmitter side, they were tris D.F2 equals to 0. Here it's 1 because here the pin has been declared as input. See, on the TX side, the pin was declared as output, so this was taken 0. So on the RX side, it's declared as input. So for the input, it is necessary that the tris register is given a command of 1. So all 3 pins have been initialized as input. Then we initialize the LCD. After that, we checked a port D.F2 pin, that is a port D.F2 connected to the D.F2 of the transmitter PIC becomes high. If it becomes high, it shows D2 is high. For how long it keeps on displaying it, this depends upon the delay on the transmitter side. On the transmitter side, the D2 is sent for 1 second. So it will keep on showing this for 1 second. See, no delay here, delay is on the TX side. Similarly for the D3, similarly for the C4, and else if all 3 are not there, then it will clear the LCD. Now this coding is giving us this result over here. See, D2 for 1 second, D3 for 1 second, C4 for 1 second, then repeats all over again. Guys, welcome to learning microcontrollers. In this video, I will show you how we can do PIC-to-PIC communication using GPIO pins. We will be using PIC16F877A microcontrollers, and we are going to use LM016 16x2 LCD with a receiver PIC to display the output. So guys, this will be an exercise, an easy demonstration for how to do a GPIO pins based PIC-to-PIC communication. Previously, in our previous lectures, we have used UART communication to interconnect 2 PICs. This time we will be using GPIO pin like our normal digital input output pins for communication purpose. So let's get started. So guys, this will be our hardware. This is one PIC16F877A microcontroller having 40 pins at the DIP version. This is our second PIC16F877A microcontroller having 40 pins. It's also a DIP version. So guys, first connect the ground to ground. Like this, ground of both the microcontrollers should be common. And then guys, there you can interconnect any GPIO pins. Unlike the UART port, which must be the same because we have only one hardware based UART port on each PIC, so you have to interconnect dedicated pins. Here this time, because we are going the GPIO communication, you can connect any GPIO pins together. So I connect D2 to D2, D3 to D3, C4 to C4. 21, 22 and 23 pins of both the microcontrollers are now interconnected. So this will be our simple hardware connection for the GPIO communication. Now, as I told you earlier, one of our PIC, we call this one the transmitter PIC and this one the receiver PIC. On the receiver side, we will be having an LCD. Whenever we send a signal like pin number C4 gets high, it will show C4 high. If D3 gets high, it will show D3 high. If D2 gets high, it will show D2 high. So for that purpose, on the receiver side, for demo purpose, we will be using a 16x2 LM016 LCD. Now let's connect this LCD. To connect this LCD, you need a 3-pin potentiometer. It has 3 pins, 1, 2 and 3 mentioned on the body. This potentiometer will be used to adjust the contrast of this LCD. So guys, the LCD have 16 pins. If you hold it like this, from 1 to 16, from left to right, if you hold it in this way. Now guys, connect the pin number 1 and 5 of your LCD like this. Connect this to pin number 1 of your potentiometer. From there, you send it to the ground of your PICs or the ground of the circuit like this. Now guys, pin number 2 of your LCD is a VDD pin connected to the pin number 3 of your potentiometer. From there you connect it to the VCC of your PIC. In this way your LCD and your potentiometer gets the 5 volt from the same source which will be powering up your PICs. In my case it will be the PIC at 3. So guys, pin number 3 of your LCD is the contrast adjustment pin. You need to connect it to the adjustable pin of your potentiometer like this. Pin number 4 is the RS pin. So for the RS pin you can use any GPIO pin. So I'm going to use the pin number D1 like this. For the EN pin, that is pin number 6, I use the pin number D0. Leave the pin number 7, 8, 9, 10. Directly go to pin number 11, that is data pin 4 of your LCD. Connect it to any available digital input output pin or a GPIO pin. I'm going to use the D4 pin. For LCD pin number 12, I'm going to use D5. For LCD pin number 13, I'm going to use D6. For LCD pin 14, I'm going to use the port D pin 7 of my PIC16F877A microcontroller like this. Now guys, these 4 pins which we left, just leave them floating, because these 4 pins, data pin 0, 1, 2, 3 are required if you are using the 8-bit mode of this LCD. But in our case, we will be using this LCD in the 4-bit mode, and in the 4-bit mode, we do not need to connect these pins. And in our application, 4-bit mode is more than enough. Now these 2 pins, pin number 15 and 16, they are for the LCD backlight. So for this, you can use any. You just have to power up the LCD backlight using 15 is the power, 16 is the ground. 5 volt from the pin 15 goes to the LED, and pin number 16 is the ground. Now your LED backlight of the LCD is also connected. In this way our connections are completed. So let me show you the hardware, then we move on to the programming. So guys, this over here is our simple hardware. See, we have 2 PICs. This is one PIC having the LCD, this is the receiver PIC, and that is the transmitter PIC not having the LCD. You can see that wiring is as shown in the presentation, rest is just a trainer board. So this will be our simple hardware over here. So let me focus on the LCD because we will need to play with the LCD. Okay, there we go. Okay, now let's get to the micro C so we can do the programming. But here is our micro C for PIC. If you don't have this, you can download this from you can just go through my lecture in which I have shown you how to download and install this from the official website. So click on new project. This window pops up, new project visit. Click on next, write the name of the project. I write PIC to PIC GPIO com. Okay, first of all we write the code for the transmitter PIC TXC1 code 1. Select the path where your files will be created. Select the microcontroller. PIC16F877A is the one I am using. Select the crystal. For the transmitter board, I have a crystal of 20 megahertz connected to pin number 13 or 14. So I select that over here, click on next and finish. Now guys, this window pops up. Before you do anything else, first of all, save your work. Okay, it automatically asks for save sometimes. Sometimes you have to do it yourself. Click on save. Okay, the work is saved. Now guys, first of all, since you know we have 3 GPIO pins that we are going to use, so we have to initialize those pins. So as per our hardware, the 3 pins are on both the PICs. It's C4, D2, D3 and C4, D2, D3, C4. So we have to, on the TX PIC, we have to initialize them as output pins. This will be sending the data and this will be receiving the data. So here they will be declared as output and here they will be declared as input. So we do it on the TX side as output, D2, D3 and C4. Okay, I write them D2, D3, C4, just a comment so I remember. So I write here trace D dot F2 equals to 0. So it's a TX PIC, transmitter PIC, so it must be declared as 0. So this will be the difference in both the sides. Trace is the direction register. Here you write the port, here you write the pin number, and then 0 means the pin has been declared as output, 1 means it has been declared as input. So on the transmitter PIC, it will be declared as 0 means output. So initially I want this pin to be low. So whenever it gets high, it means it will send a signal to the other PIC equals to 0. So by default it's low. So we give some initialization delay, not necessary, but I always suggest you give it in the one-time loop. Okay, this is first pin initialized of the transmitter PIC, second pin, third pin. Just rename them. For the second pin we have D3, so make it D3, D3. Okay, that's fine. For the third pin we have C4, so change the port first, C4, C4. Here you go, all three pins initialize. Now we go for our forever loop, while one forever loop starts here, ends here. Inside the forever loop we write our code. So what we should write, like we just want to send signals, so we send signals in sequence, okay, one by one. For 1 second it will send this and will pause the code for 1 second. It will keep this high for 1 second, then this will go low and this will turn high for 1 second, then this will go low and this will turn high for 1 second. So that's simple code we write. So I write here, so by default port D.F2 is low, we make it high. Port D.F2 is high, then we wait for 1 second, that is 1000 millisecond, like this. After that we make this go low again. Now port D.F2 is low and we make this go high. Port D.F3 by default it's low, so make it go high, and then we again pause the code for 1 second. We wait for 1 second. This means that it remains high for 1 second. After that we make this go low. Here you go. Now we make this go high, port C.F4 for 1 second, like this. Now guys, after that C.F4 will go low again, so we make it on the top or just after the code, both will do fine. Okay, here you go, it will go low again, and after that the code will repeat again, the first one high, second high, third high, and then again it will keep on repeating forever. So what we expect from this code is that when it starts, it will initialize port D.F2 pin, D.F3 pin, C.F4 pin. Then guys, it will turn the port D.F2 pin high for 1 second. After that it will go low, and then again port D.F3 will turn high for 1 second. After that it will go low as well. Then port C.F4 will turn high for 1 second. After that it will go low, and it will keep on repeating forever. So we build this code, no errors, perfect. Build it again. Okay, it's perfect. Now we burn it into our microcontroller. Open the PIC3 programmer tool. Wait. So here we go. This is our PIC3 programmer tool. So first of all, you select the microcontroller. PIC16F877A is the one I'm using. This one. Click on File, import hex file. This is the file we just created. Double click. Okay. Now first we make sure that our PIC is connected. PIC3 is connected to the right PIC, the transmitter PIC which we are burning. Okay, it is. Okay, that's perfect. Now we can burn the code. If you don't have this PIC3 programmer tool, you can just go through my lecture in which I have shown you how to download and install this. It's a free tool. Okay. Okay, again, just to make sure that we are doing the right file. Okay, click on write. Wait. Okay, it is doing the programming. Okay, until the programming is done, we just go and start writing the receiver side code. So go to your micro C4 PIC. Okay, here you go. Now we write the code for the receiver side. Click on File, New project. Click on Next. Write the name of the project. Okay, instead of TX, we make it RX. Rest will remain the same. This is the path where your files will be created. It's like the microcontroller PIC16F877A. The crystal I have at my receiver board is 16 megahertz connected to pin number 13 and 14. So this is fine. Click on Next, Next, and Finish. Now this window pops up. Before you do anything else, press Ctrl S to save your work like this. Now guys, what we have to do is that since on the receiver side we also have an LCD, then we have the same 3 pins. So we go to the transmitter side code, this one, copy these commands which we use to initialize these pins. Go to the receiver side. First we initialize the 3 pins as input pins. So you can see that on the transmitter side I have declared them as output because it's 0. So if it's input, then it will be 1. So just you have to change this. Instead of 0, now it's 1 because these pins are now initialized as input pins on the receiver side. Now we initialize LCD. To initialize the LCD, go above the void main, go to the right. Here you have this micro E libraries expanded, the system library is expanded. Go down there, you have this LCD library expanded. go down, there you have this LCD out command, double click on it. Oh sorry, LCD I90 command, this one, double click on it, LCD I90 command. In the example here you have these commands, copy them till here above the dots like this, go back, go to the go and paste them above the void main like this. Now guys, first of all you have two sets here, pin direction and pin out setting. Here whatever the pins you have selected on your hardware, you will just write them here. For the LCD RS I have selected D1, for LCD EN I am using D0, for data pin 7 it's port D7 pin 7, for data pin 6 it's port D pin 6, for data pin 5 it's port D pin 5, for data pin 4 it's port D pin 4. Now this was for the pin out setting and this is the pin direction. Do exactly the same which you did here. D1 for RS, D0 for EN, D7 for D7, D6 for D6, D5 for D5, D4 for D4 like this. Now guys, go to the right again in the LCD I90 command in the LCD library, double click on it. Below these commands you have this command called LCD I90. You have to copy this, go back, paste it in the one-time loop like this. Now this command will initialize the LCD with these pin out setting. So that's all you need to initialize the LCD. Now guys, we just give some initialization delay for the LCD as well. 200 milliseconds will be fine. Now guys, we go for the forever loop. Write down while one. Forever loop starts here, ends here. Now inside the forever loop, we have to do the programming against these incoming data over the TX PIC through the GPIO channel. So what we do is that we go back on the RX side. Now we make a loop here. If first of all we have this pin port D.F2, if port D.F2 double equals to 1. By default, you know, it's 0 because here you can see that we have set it to 0 by default. If it becomes 1, then what it will do? If port D.F2 double equals to 0, then it will display on the LCD. So go to the right, there you have the LCD library. In the LCD library, you have this command called LCD out, double click on it. There you have this command LCD out, you copy this command, paste it inside the loop like this. Now start writing from the first row, first column, what it should write. It will say high at D2. Okay, this will be fine. That D2 pin is high. D2 is high. Okay, that's fine. And then it will keep on displaying this for, like, I call it 1000 milliseconds, so we can see it. Okay, 1000 is too much. We just remove the delay because delay is given on the transmitter side. See, we have already given delays at the transmitter side, so no need to give delays at the receiver side. So it will be automatically done by the transmitter. After that, we again copy this loop, we paste it here, and instead of if, I write else if. Else if port next one is D.F3. D.F3 becomes high. Then it will show D3 is high. And again else if C.F4 becomes high. Then it will show C4 is high. So in this way, if you want to do anything else, like if I want this to drive a motor, other PIC is sending me a signal that this PIC will drive a motor connected to it over the H bridge, you will just write your code inside it. Whatever the code you want to initiate after getting a signal from the other PIC, you will write inside it. It is just an example. The LCD is an example. You can write any code inside it of your choice, whatever the application you have. So else, if none is received, then it will clear the LCD. Okay, now go to the right in the LCD library. You have this command called LCD CMD, double click. And in the LCD CMD, in the example here, you have this command LCD CMD LCD clear. Go back, copy it, else in the else loop. Else it will clear the screen. Okay. Okay, now we build this code. It's built successfully. Okay, now I have to burn it. So guys, there we have the PIC3 opened. First of all, zoom in, go to the file. Okay, PIC16F877 is already selected. Click on file, import hex file. This is the file we just created for the receiver PIC. Click on double click. Okay, before you click on write, make sure that your PIC3 is connected to the receiver PIC. So for that I check, okay, it is connected, that's fine. The receiver PIC is the one having the LCD, so it is connected to the right port. So now we open the PIC3, here it is. Okay, there we go, the file has been selected. Okay, I power up the circuits and click on write. Okay, let's wait. Erasing device, you have to wait. It is programming device data, wait. We have already powered up the circuit using the PIC3, so we don't have to click over here again after the programming is done. So we just have to see the code works or not. So I bring it here. Okay. See, the code is working. We are getting data from that side. Now see, D2 high, D3 high, D4 high. D2, D3, D4, okay, C4, sorry. So it is working perfectly fine. See, that is just a cursor, don't worry about that. D2, D3, C4. You can also turn off the cursor as well from the LCD library. There is a command called in the LCD CMD to turn off the cursor. Our code is working perfectly fine. You can see that it starts from D2, D3, C4. That is what it should do. Now take a look at the transmitter code. On the TX code, you can see that we first wrote the D2. After 1 second, it will be the D3, and after 1 second, it will be the C4, and after 1 second, it will repeat all over again. Now that is exactly what it is doing. So we have established GPIO communication between the two PICs successfully. So guys, this was it for this lecture. If you guys have any questions, you can ask. So we'll see you in the next lecture. Goodbye.